Okay, so what do we have? We got a person jumps from a roof of a house. It's gonna be 20 feet high, so that's a 20 feet drop. And then he bends his knees. Okay, so while he's bending his knees, the torso is gonna decelerate over a distance of 2 feet. All right, so the mass of his torso is given. So what's the velocity just before his feet strike the ground, and the average force exerted on his torso by his legs? Okay, so I'm just gonna list this first. Okay, so he's gonna be falling 20 feet. All right, so what do we? This is the center of mass. So this guy's just jumping down, and the ground is gonna be located right here. Okay, so when the feet make contact with the ground, center of mass is gonna be here somewhere. All right, so he's gonna bend his knees and he will decelerate over a distance of 2 feet. Okay, so I don't. All right, so let me just add a notation here so we don't get things confused. All right, so he's gonna decelerate through this distance. I'm gonna make this y prime. Okay, so that's about 2 feet. Yeah, what else do I want to use? Okay, so the torso is gonna have that mass. It's gonna be 95 pounds. Okay, so his velocity just before he strikes the ground. All right, so let's make this A. Okay, so this is his speed just before he strikes the ground. In terms of meters per second, miles per hour. Okay, so what else do we have? And let's figure out the average force. B is the average force. In terms of newtons to pounds. Okay. Okay, so I'm gonna do formula hunting. Okay, let me go to the formula sheet. Pick some of the relevant formulas for this case. Okay, so what's relevant? All right, so the relevant formulas for this case are here. So there's gonna be a force. Acceleration, this is the average acceleration. If this is jerking motion, this is gonna be the average force. This could be the uniform motion formulas as well as you got the free fall formulas. So let me also just grab the free fall formulas. Okay, so I'm just grabbing anything and everything that I feel relevant that we can use. Okay. Okay, so I grabbed a bunch of formulas. All right, so here's my treasure chest. Okay, so this is my toolbox. Okay, everything that I think I can use is going to be there. All right, so the first part of the motion. Okay, before we go forward, okay, let's do some house cleaning. 20 feet, 2 meters, 2 feet, 2 meters. If you have the numbers, give me the numbers.
6.1 meters.
6.1. Give yourself 5 points. 2 feet.
It's just a tenth of that.
All right, and 95 pounds.
43.18 kilograms.
Okay, so give yourselves 5 points for every single answer. Okay. All right, so we did the house cleaning. Okay. Okay, so this distance is this distance. Okay, so this is the distance along y. Okay, so that's happening under the influence of gravity. All right, so gravity is the only force acting in free fall. Okay, yes, this portion is free fall. Boom. So these are the equations. That portion is free fall. Okay, so what's the initial speed? Initial speed on the y direction is going to be 0. Okay, so initial speed on the y direction is going to be 0. All right, so this is going to go to 0. This goes to 0. This goes to 0. Very good. Okay. We're not given time. Okay, so we don't know how long it's going to take. This thing is not given. Okay, so which means that formulas that have time in it, so this is not good, this is not good. So the only formula that makes sense to use is this one, right? The very last one. Okay, so let's use that one. All right, so for part A, we will get to use this formula. And we just discussed that. So that term is going to be 0. And then take the square root of both sides. Okay, and then we're done. Okay, so that's the speed. All right, so give me the speed in terms of meters per second and convert it to miles per hour.
11.04 meters per second.
Okay, give yourself 5 points. So what is this? This is what, 22, 20, is it 25? 24,
Yeah, it's roughly 25.
25 miles per hour. Okay. Miles per hour. Okay, so give yourself 5 points for that one. All right, I mean, literally, this is 20 feet drop. That's like jumping from the second story of a building, second floor of a building. So you hit the ground at 25 miles per hour. This is not bad. And then what do? You bend your knees. All right, so you bend your knees and you will come to a stop within a distance of 2 feet. Okay, so within that distance, you will come to a stop. So what's the force, if that's the case? Okay, so force is what I'm looking for. And I'm going to just use my own approach for this one. I told you guys about my preference. My preference is always just direct attack. So just start with the force formula, which is right here, and then check to see what we could do with it. Okay, here's the force formula. Okay, so we know the mass. This is what we were looking for. So now figure out the acceleration. Ideally, I want to use this acceleration because the body's going to go through jerking motion. Okay, I mean, you can't bring yourself to a uniform stop. So acceleration is going to change. So I want to use the average acceleration formula. So that this is going to give me the average force. Okay. Except I'm looking at my toolbox, and my toolbox says, try your best. This is not going to work because I don't know the impact time. All right. I mean, this is the best that I could do. I don't have the impact time. I want to use this. Ideally, realistically, this is what I should be using. But there's no place I could get this impact time. So what that means is I have to assume the acceleration is going to be constant. And that assumption is going to give me an approximation. All right, this is going to give me a polar approximation. So this is what I want to use because I don't know this. I won't be able to use it. Okay, so which means that I have to get my acceleration from here and then substitute here. So obviously we don't know time. We can't use this. It's for the same reason you cannot use this. So this is the only thing that you can use. All right, so what happened here? So what's happening here is right at this point, your feet is going to touch the ground. Right here, your feet is going to engage. And then you're going to bend your torso. Okay, so what's happening at this point is you're already moving in the downward direction. At that point, you have this velocity in this direction. Final velocity is going to become your initial impact velocity. All right, so that initial impact velocity that you're looking at is the same as this velocity. And then what happens? And then what happens is you will, within that distance, you're going to come to a stop. All right, so this is going to be your initial impact speed. So your final impact speed is going to be 0 within a distance of 2 feet, which happens to be 0.61 meters. So the question is, what is your acceleration within that time period? It would be interesting to find the G load as well. Okay, so which means that for this A, we will get to use this formula. All right, I goofed it up. Get out of here. This is the formula we're using. All right, so final speed squared, the initial speed squared, 2 times, 8 times. Okay, so instead of using x, we're using y prime. Okay, so this is what we're using. So which means that I'm going to change the formula to y prime. Okay, so within that distance, we will come to a stop. Okay, so what do I know? I know that the final speed is going to be 0. And figure out the acceleration from here. Okay, so get rid of the initial speed. All right, so get rid of 2. get rid of y prime. Okay, almost got distracted there. Okay, so we came up with an expression. Normally, I don't want to plug numbers in at this point because it's not necessary. But out of curiosity, I'm always curious about acceleration and impact. So let's just get the number just for the hell of it because it's an interesting problem. Okay, so I haven't done these problems before, so I made them up or I got them from somewhere because they seem interesting. So let's add a page. Okay, so let me just, okay, go ahead.
The acceleration would be about,
Hey, Jack, you got cut off.
oh, the acceleration would be about 30 meters per second square.
Okay, are you kidding? That's weird. 30 meters per second squared. That's about 3 Gs. Huh? Are you kidding? That's so weird. Is it realistic? It's about 3 Gs. Okay, so which means that you're bending your knees for 2 feet. Okay, so okay, you're bending your knees for 2 feet. Is that even realistic? Yeah, that seems reasonable, right? Then again, that's 20 feet drop. Okay, 3 Gs seems, yeah, why not? Because yeah, okay, that seems reasonable. So you will feel about 3 times heavier. Okay, that makes sense. Because that's not a bad distance, yeah. I mean, it's not going to break your bones or anything. Cute. And of course, it's going to be a negative acceleration. Okay, so we're good with that. Okay, now the back substitution. All right, this is supposedly the average force, but that's actually a uniform force. All right, so this is the box equation. Okay, so what would you get out of this? This person's torso is 95 pounds. I wonder why they focus on the torso as opposed to the entire body. That's weird. All right, so what do you get in terms of newtons?
I don't know if this is right, so I was hoping somebody else did it too, but I got 1,315.7.
1,000.
That feels like a lot.
I got 1,295.
I got
Either way.
1,306. So in the ballpark.
Okay, we suck. This is awesome.
All of you guys give yourselves 5 points. You guys are in the ballpark. Okay, I don't know which one is exact, but 1,300 sounds right to me because it's in terms of newtons. Okay, so what is this in terms of pounds? Okay, so it's going to be about 3 times this guy's torso weight. All right, so 95 pounds. So it's going to be close to 300 pounds, right?
Yeah, I got 287.
Yeah, it's like 290.
290. Okay, cool. That makes sense. Okay, numbers worked out. Okay, guys, this is a little bit more involved, but you can all see that its numbers are making sense, right? When we investigate. I mean, it's jump from the second floor. You're not supposed to be breaking a bone. So that makes sense. Okay, so 3 Gs here is going to make sense. And it's the torso weight goes up almost up to 300. Okay, the thing that I don't get, this is the weird thing. So this is not something that I made up. I wonder why they're just focusing on the torso as opposed to the whole body. So that's a weird approach. Okay. All right, so, okay, so it's 8:28.